Hello everyone, I'm Paul and today we're solving problem 326, power of 3. This is an easy one with many different possible solutions. So here I'm going to show you what's the overall intuition and then I will show you my efficient solution. So let's start. Our job is simple. We are given an integer n and we need to return true if it's a power of 3, otherwise we return false. So let's say n is 27. In this case, we return true because this is a power of 3. More specifically, this is 3 to the power of 3. Now let's see what's happening here. This is the base 10 representation of this number. Now we are looking for powers of 3. So we can see this as the base 3 representation of 27. And this is 1, 0, 0, 0. And in case you don't know how this works, let's say that we want to go from the base 3 representation to the base 10 representation of this number. We go from right to left, and for every position we do 3 to the power of the current position. So we start with 0. And next we have 3 to the power of 1, 3 to the power of 2, 3 to the power of 3. And now we do 3 to the power of 0 times 0, which is 0. 3 to the power of 1 is 3 times 0 is 0. This times 0 is 0. And 3 to the power of 3 is 27. So now we sum these values and the result in this case is 27. So this is how we go from this base 3 representation to the base 10 representation. And we see a pattern here. We know that the result for this is true because we have a 1 in the leftmost position and then every other position is 0. So if we see this pattern, we know that n is a power of 3. And there are many different ways to solve this. Here I will show you a very simple approach. We are iterating this representation from right to left. So first we are here and we'll have a variable, we'll call this scene1, and this is a boolean. We'll say this is initially false. And first we are here, and if we find the 1, we'll change this to true. Given that we have a 0, we continue with the next position. Now we have another 0, so we continue. Here we have another 0, so we continue. And here we have a 1, so we can change this to true. And now we reach the end of this number, and given that this is true, we just return true. Now let's say n is 26. Here we have the corresponding base 3 representation, which is 2, 2, 2. And we are doing the same here. We are iterating this from right to left, so first we start here. And given that this is not 1 and it's not 0, we are already breaking our pattern here. Remember that we are looking for a 1 in the leftmost position, and then every other position has to be 0. So given that this is not a 1 and this is not 0, we can break this loop right away and just return false. Now let's say n is 25. First we are here, and given that this is 1 and this is false, we change this to true and we continue with the next position. Now we are here, and given that this is not 1 and this is not 0, here we are already breaking our pattern, so we just break this loop and we return false. Finally, let's say n is 22. Here we have the base 3 representation for this number, and we do the same. First we are here, this is 1, and given that this is false, we change this to true. Next we are here, and this is 1, but given that this is true, we can just return false. And why are we returning false? Because we are breaking our pattern here. Remember, the only valid pattern for this to be a power of 3 is if we have a 1 in the leftmost position and then every other number is 0. So if we have 2 1s, we are already breaking our pattern. That's why we return false here. So this is basically the entire approach. Now, as I said before, if you understand this, you can try different ways to solve this problem. The main thing here is to understand this part. So now let's go with the code and hopefully you will get the idea. First we have our boolean sin 1, and this is initially false. And now we are iterating every position in the base 10 representation of n. So we say while n, we reduce n, meaning n divided equal 3, and we use 3 because we are working with base 3 representation of n. And before this we say if n modulo 3 is 1, and here we are checking if not sin 1, sin 1 is now true. Else, meaning if sin 1 is already true, we can return false because we need only one number 1. And now we can say if n modulo 3 is different from 0 or it's equal to 2, it's the same. Here we just return false. And finally we can return sin 1. So now let's submit this and see if it works. As you can see, this works and it's very efficient. So if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.